So now that we're done with the repository layer, we can now move on to the service layer. As you can see, we're here. Service class files are used to write business logic in a different layer to separate it from the controller, right? Because the controller, we receive the request from the client, but we don't want to have to write everything all in one file, right? It's good to have some layers when it comes to it, right? So we have the repository layer to communicate with the database. We have the controller layer to actually receive the request and making sure that the request is in the proper format. But then we have this service layer that handles the business logic. So we just want to make sure that the controller has the ability to make sure that the data is formatted as expected and to send it off or to pass it off to the service where the business logic can be handled. So what do I mean by the business logic? Well, it just means that if you need to extract data or if you need to like reformat data to send it off to the repository to save that information, or if we need to receive the information from the repository and format it in a way that the user will understand, that's the logic that can be done from the service layer, right? There may be some cleansing that needs to be done that can't be done from the repository and that can't be done from the controller, but it definitely can be done from the service portion of the application. So we receive the information from the controller, the request. We get that information, making sure that it's proper. We maybe have to put it into a format that the repository can understand to save into our transaction table or to save into our user table or our accounts table. And then we get that information back because remember, the repository is going to attempt to save it, right? So when it saves it, it's going to receive an ID. And then once we get that information back from the repository that we know that it succeeded to save that information, then we get that information back to the service. We format it again in a nice format for the user. We send it back off to the controller again, and that controller sends it off to the client. So it's going back and forth if everything goes well. And in the future, we'll talk about the global exception handler, where in the case there may be issues along the path of maybe something goes wrong in the service, so maybe something goes wrong in the controller, maybe something goes wrong in the repository, then the global exception handler will clean that up. But the service in this case will handle making sure that everything goes smoothly between the controller and saving the information in the repository and then getting that information back there from the repository and handing it back to the client through the controller. So it's it's very team oriented when it comes to all these layers. Now, something that I want to talk about really quick is inversion of control, right? Inversion of control is a principle in software engineering which transfers the control of the objects or portions of a program to a container or a framework. And the framework in this case is Springboot. If you haven't noticed already, everything being utilized is essentially an instance of a class, which is an object, right? We define our controllers, we define our entities, and in the future, in this case, services, as a class to utilize, and it will be an instance of, guess what? An object. But the cool thing about Spring Boot is that it will handle the creation of these objects for us automatically. This is why the annotations are so important. We saw the at repository, we saw the at controller, and soon we're going to see the at service. Spring Boot will then scan these annotations like at repository or at service and create the instances of the object when the application starts. So when we need to be able to communicate with our database, well, it's going to create an instance of our repository to communicate with our transaction table or to communicate with our accounts table using inversion of control, right? Because we're not creating the instances of the object ourselves. With these annotations, when the application starts up, it's going to create the instances automatically for us. So that is inversion of control in a bigger sense and why it's so useful. Because imagine having to create an instance of the object every single time. That would be crazy. But with inversion of control, we allow Spring Boot to handle that for us. And then in collaboration with inversion of control, we have dependency injection. Dependency injection is a pattern that we use to implement inversion of control, where the control being inverted is setting an object's dependencies, connecting objects with other objects, right? And in this case, right, dependency injection, injecting objects into other objects. All right, so an example to help drive this home, right, inversion of control and dependency injection, we can see the typical approach, right? If you took your normal Java course or Kotlin course, you know this approach of you have a class, right? And in this case, it's going to be called account service. And you have a couple of variables, right? And right now they're empty, but on the creation of the instance of this account service, right? On the object creation of account service, we'll then initialize those variables that we created above here with the instance of, in this case, account repository and user service, right? And we'll have to do that for every single class that has dependencies that it needs on startup, right? We would have to have a constructor and we'll have to create variables to hold an instance of, that dependency that we need. But with dependency injection, all we got to do is pass it as a constructor value, right? And in this case, Springboot will inject the dependency automatically into it. So in this case, we have, as you can see, account repository, just like how we have here. We don't need to make it equal to account repository anymore, like the typical approach. Once Springboot sees that you have these values in the constructor, it's going to realize, oh, you have a at repository annotation on this value here, and you have an at service annotation on this value here. And let me go ahead and inject that into these values so that you can utilize inside of your account service class. So on a broader scale, on a bigger scale, right? The at, whether it's service or repository, it's a specialization of the at component annotation. And these annotations can be applied to classes, right? The Spring context will auto detect these classes when the annotation is provided and scan it and create these instances when we need them, right? It'll inject these instances where we need them. So in this case, we had an at repository on the account repository. So when it sees it, it's going to inject it. When we see when it sees a service, because we use the at service annotation, or we will be creating a at service annotation pretty soon, is going to inject it into every service that it sees when we specify it. That's just the power of inversion of control and the power of dependency injection. It saves time and it saves the headache. And another way that we can do the same thing is we can use auto-wired, right? So we can specify it inside of the class, and what auto-wired is going to look for, right? It's going to look throughout, the context and try to find the specific instance of the user repository, and it's going to inject it into this user repository variable, right? That's why I'm using the latent net here, because it's saying eventually I will get this instance and I will inject it into here, right? But uh, honestly, I don't really like using auto wire anymore. I like using it directly in the constructor because of the fact that when it comes to testing, it's easier to test with this approach rather than the auto wire approach. But I thought I'd just show you guys both ways to do it. So that is the power of dependency injection. I hope it clears that up. If you have any questions, just let me know. But this is the typical way, and with inversion of control and dependency injection, this is the approach I will be taking going forward. All right, so here I am back in the IDE, and what I want to do is close these up, and I want to right click on service, and I'm going to create a new Kotlin class, and I'm going to call it funds service, right? This is where it's going to handle the business logic in regards to funds, right? So whether it's deposit, withdraw, all that logic of doing the math of making sure that the balance is proper, or making sure that the user even has an account, or that the account that the user is sending to is valid, all that logic is going to be encapsulated inside of the service layer, right? We don't want to do that from the controller layer because we just want to handle the request from the controller. And we don't want to do that from the repository because we just want to use the repository to interact with the database, right? When it's time to save, when it's time to retrieve, when it's time to update, that's what the repository is for. But when it comes to doing logic, right, the math and making sure that everything is proper and that the values actually exist, that's all being done from the service layer. So let me go ahead and create that. And from here, Springboot is all about annotations, right? And just like how I talked about when it comes to inversion of control dependency injection, these annotations are very important so that Springboot can scan and look for exactly what it needs to eventually inject it where it needs to be injected to, or create it where it needs to be created. So in this case, it's going to be an at service, right? So we've seen at controller before, we see at repository. In this case, it's going to be at service. And import that. And we're going to see a little bit of dependency injection magic, right? So let me open up this constructor. And what I'm going to specify here is I want an instance of the transaction repository. So transaction repository, which we just created. And now what this is going to allow us to do is in our fund service class, we're going to be able to interact with our transaction table, right? So with the instance of a transaction repository, which is automatically injected, right? When an instance of this fund service is being created, it's going to say, oh, Okay, let me look for the transaction repository. It's going to go into the transaction repository, see it has the repository annotation, create an instance of that. It's already going to have an instance of the repository created, and it's going to inject it into this instance of the fund service, and now we can utilize it in any way that we want to. So if I need to do transaction repository save, or if I need a find, then I can just use dot notation and I can grab the method that I want to. Just to see an example, right? If I create and I'm putting Python, but if I create a function and let's call this deposit, right? And I open this up, now, now through the magic of dependency injection, all I gotta do is do transaction repository dot. And now I have access to all these JPA repository methods, whether it's using the custom one that I made, find by user ID, or using find by, or all these other methods that JPA repository provides. I can use that and it'll work because of the fact that with dependency injection, it already created an instance of the transaction repository. So this will work, right? Or I can go the approach of using AutoWire, which I really don't like using, but it is an option, by doing private, and then I can do latent it var, and then I can specify the transaction repository, and it's gonna be mad initially because I already have transaction repository here, but this will work. I will still be able to have access, right? It's gonna, when the fund service is created, it's gonna go ahead and inject that instance of transaction repository into this instance right here, right, into this variable, and I can use the dot notation and I can um, communicate with my database, right, from the fund service. That is possible, but I like using um, the constructor approach directly instead of using AutoWired because, like I said, testing becomes a lot more easier when you can just inject, uh, test versions of it directly through the constructor instead of having to depend on AutoWire. So yeah, dependency injection is pretty cool in that sense of it's gonna go ahead and look for the transaction repository, grab that instance, and inject it into this variable for us. Now we can use it throughout the class with no issues. So that's really with any dependency, right? If we want to inject objects within objects, it is now possible, right? So from the fund service, we can inject transaction repository, or if we need the user repository, anything that we'll need, we can grab, right? Because dependency injection makes that possible. So from this fund service, I'm gonna do some basic methods that we'll need in the future. So this first one is already a startup for it, but I'm gonna rename it to handle deposit. So this is what we're gonna use to handle deposits. When we receive a request for deposits, then it will execute this method to make sure that we grab the proper account, we add that balance to the account, and we save that new balance, right? So this will be where the deposits are handled. And what are we expecting? Well, we're expecting a fund DTO, a funds DTO, right? Because remember, we created a data transfer object for funds. If I go back just for clarity, and it's in the format that we expect, right? We have the account ID, we have the amount, and there may be a case where they send an email or provide an email. That's also provided as a property, right, in the funds DTO and the funds transfer object. And we'll pass that to the handle deposit method, and we'll also need the user ID of the person creating this transaction or doing this transaction. So we know that the user ID, especially in the future, is going to be provided in the JWT token, but we got to make sure that we provide that user ID when we call this method to handle the logic for us. So that is going to be there, and it's going to be of type long. So for handle deposit, a user will have the ability to deposit an amount to their account. So we'll check if the user exists and add that amount to the user account if that account is associated to that user. And we'll also have to have some logic that checks if that account is associated to the user. Now, if it's successful, we'll return a newly entered transaction. Transaction meaning we're storing the information regarding that transaction. In this case, it's going to be a deposit. We're going to save the fact that a user deposited into an account so that if they go into their statements, they'll be able to see all the transactions that occurred when it comes to their account. So for the logic of checking the amount and whether a account is associated to the user, we'll do that in the future. But for now, I'm going to go ahead and create the logic of saving a transaction to the transactions table. So let me go ahead and create an instance of transaction, and it's going to be of type transaction, and it's going to be equal to a transaction, right? An instance of a transaction from the entity that we created, right? And then go ahead and do transaction dot user ID is going to be equal to the user ID that we're passing through the parameter, right? The user ID is going to be who created or who is trying to deposit into the account. So, and then we're going to do transaction dot amount. Transaction dot amount is going to be equal to funds DTO and the amount that's in the funds data transfer object, right? So the difference between the transaction and the amount table is that for amount, we're going to have to add the amount to the current balance in the account table. But in the case of transaction, we're just going to store the whole amount to the transaction because we're trying to make sure that we keep a history of all the transactions that occur. So that's the difference. So then for transaction, we're also going to store the transaction type. And in this case, I'm going to do that myself because I know for handle deposits, we're only going to be handling deposits. So the transaction type is going to be transaction type.deposit. Now with dependency injection, we injected the instance of transaction repository here. So what we can do is we can do transaction repository, and we can use a method to communicate with our transaction table through the JPA repository, right? So you can see that it's already popping up, some of the methods. And what we're going to need is the save method to save the entity that we created right above here, which is transaction. So in here, we'll just place transaction. And what this will do is going to save that transaction to the transaction table. And then after that, we're going to go ahead and return that newly created transaction. And like I said, in the future, we're going to go ahead and also I got to specify what type that this handle deposit is going to return. And in this case, it's going to be a transaction. So this is where all the business logic is going to occur in the service. This doesn't need to be done in the repository, or this doesn't need to be done in the controller. This can be its own separate layer just to save space and just to be able to handle all that logic within one space. Every layer has its own specific task that needs to be done. Instead of putting it all into one file, we can delegate it amongst different layers. Now the second business logic we'll write is for handling withdrawals. A user has the ability to withdraw an amount from their account, and we'll need to check the amount a user has in their account before withdrawing. If the user has enough, we'll deduct the amount. If they do not have enough, we'll have to deny the request and inform the user that they do not have the proper amount to withdraw. And if successful, we're going to return the information regarding that specific transaction. So what I'm going to do is go ahead and just copy this just to save time. And I'm going to paste it right underneath. And I'm going to change the fact that first this is going to be handle withdraw. It's still going to be the same logic of it's going to be a funds DTO, but the funds DTO is going to hold all the data related to that specific withdrawal. And the second parameter is still going to be user ID because we're still going to be storing who exactly is attempting to withdraw. So we're going to make sure that it's from this specific user ID. And then it's still going to be the same logic in the fact that it's going to be a transaction. We're going to save that user ID. We're going to save the amount that the user is trying to withdraw. And now in this case, it's going to be transaction type dot withdraw. And then we're going to save that transaction and return that transaction. So we're just saving the transaction for withdrawal, and then we can move on to the third business logic. So the third business logic will be to write for handling transfers. A user has the ability to transfer an amount from one account to another account, as long as the accounts are associated to themselves, right? So if they own the accounts, they can transfer between accounts. So you may want to transfer from a savings account to a checking account, or from a checking account to a saving account, or from a saving to another saving. All of that is possible using transfer. So the logic behind that will be we'll need to check that the amount a user has in their account is enough to transfer it to another, right? If the user has enough, we can deduct that amount and send it to or transfer it to the other account. We also have to check if the user even has the other account. So making sure that both accounts exist. And if they do not have enough to transfer, we'll deny the request and inform the user. And if successful, we'll go ahead and return that transaction back to the user to inform them that it went through. So same concept. Let me go ahead and paste that in. In this case, I'm going to put handle transfer, and same parameters, right? It's going to be funds ETO, user ID. It's going to return a transaction. We can keep all of this actually, and then just change this to transfer. Actually, dot transfer capital, and it's just going to save that transaction and return it. So the last business logic will be handling send, right? So I talked about it before. It's going to be like a Zelle, it's going to be like a Cash App, or Venmo, right? A user has the ability to send money to another user as long as that user has the proper amount and as long as the other user exists, as well as the account that the user is trying to send to is actually a real account, right? So before we talked about, or I talked about, the fact that each user should have a default account. So I would check if that user has a default account to put the money on. If it doesn't, then we're just going to deny the send request, informing them that there is no valid account associated to the user that they're trying to send to. And if they do have a default account to put the money on, then we're going to go ahead and provide them that money or send that money as long as the user that's trying to send the money has the proper amount of money. Now, if they do, then we'll go ahead and inform the user that it went through by returning the transaction, right? We're returning the amount, returning the type of that transaction back to the user. And if not, then we'll inform the user that something went wrong and provide a message back to the user on why it went wrong. So that's handle send. So we have the 4 business logic when it comes to the fund service. In the future, we're gonna dive in a bit deeper and add some validation and add some logic, but this is the bare bones skeleton of the fund service, and we're saving all of that information into the transactions table. Now, the next service I'm going to work on is the user service. So the user service will contain code and logic related to the users using our application. So I'm going to go ahead and right click on service, Kotlin class, call this user service, and then go ahead above here, add the annotation of service. And for the user service, what we're going to need is we're going to need an instance of the user repository. So using dependency injection, what I'm going to do is from the constructor, I'm going to inform that I need an instance of the user repository. So when I go into the user service, it's automatically going to inject an instance of the user repository for me to communicate with the user database or the user table. So one addition that I want to make in the repository, or specifically the user repository, is a name method called find by email. And what this is going to do is it's going to help me find a user by their email. So I'm going to create it here, and I'm going to do find by email. And what I expect is I'm going to expect an email, and it's going to be of type string. And what I'm going to utilize is I'm going to utilize an optional, right? An optional is a built-in class provided during Java 8, and we can also use it in Kotlin. And it comes with a lot of built-in methods, right? So go ahead and do optional, right? And I got to import it. And I'm going to specify user here. So optional, it comes with built-in methods which allow to check if a value is present or if it's empty, right? It also allows us to throw exceptions if the value is null using or else throw. And there's a lot more methods that optional provides. So in this case, I'm going to attempt to find an email or user by email. And with optional, I can go ahead and check if I was able to find a user from the users table. And if not, I can go ahead and throw an error to inform the user that, or to inform the person trying to send the money or any other type of logic, that this user does not exist by this specific email. So I thought this will come in handy, especially when it comes to sending money, right? Like Zelle, if you utilize Zelle, you can go ahead and send money using email, username, phone number. So in this case, I can use the find by email, and if I can't find a specific user by their email, then I can go ahead and inform the user that you can't send money to this user because this person doesn't exist by the email that was provided to you. And what optional makes it easier to check if the value even exists. So that's the reason why I'm using it. So back to the user service I go. All right, so the first method I'm going to create is the get user, right? So I'm going to attempt to get a user by email. Right? I'm going to make it very specific and inform them that they got to provide the email of the user. And what is going to be returned is an instance of a user, right? And I got to import that from the entity, right? So let me go ahead and import that. And I'm going to open this up, and it's going to be a quick little one-liner of user repository, which I have above. And I'm going to do find by email and provide the email that was provided. And now it's going to throw a little squiggly right now because it's going to be like, okay, you want a user to be returned, but right now this find by email is returning an optional of user, right? But like I said, optional comes with a lot of predefined methods that are very useful to check if a value actually exists and what to do if it doesn't exist. And in this case, I'm going to use a method called or else throw, right? Now, if it exists, then it's going to go ahead and return the email automatically. But if not, I'm going to go and throw an exception. And in this case, it's going to be just an exception and regular exception, and it's going to provide a message of user not found. Now, right now, this is nasty, right? Like we don't want to just throw random exceptions anywhere in our application, but this is going to be a first edition, and later on we're going to upgrade it to be utilizing a custom exception when we add our global exception handler. So when we throw an exception, our global exception handler is going to be able to reformulate it in a way that the user will understand. So we're going to pass this message of user not found, and then in the future, our global exception handler is going to grab that, provide the proper status code. We're even going to create custom exceptions. So it's not even going to be called exception anymore. It's going to be called something else. But, or in this case, it's going to be user not found exception, and we'll go ahead and formulate it in a way that makes sense to the user. So for right now, it's just going to be a regular exception. But I just want to show how cool the optional is because it's going to allow us to use a method like or else throw to check whether a value exists. And if not, then we can handle it in a way that we want it to. So the next method I'm going to create is just a method to save the user. So in the case of something like sign up, right, when I need to save the user, I can do it using this save user method. And what I expect is I just expect the instance of user, and what's going to be returned is going to be the instance of user that was saved, right? Because when I save the user is going to provide, things like ID, right? And I'm going to need that. So what I'm going to do is save that user and going to return an instance of that user. And I can return the instance of the user that is returned by the user repository.save. So provide the initial instance of that user, right? And then go ahead and return that back to the user with the new ID. Or if you're doing an update, you can also use the save user as well, right? If you're going to edit it, then it's just going to save whatever is in this instance of user, right? So you can use it for adding a new user, or you can even use it for updating a user as well. So this is really all we need for the user service for now. And the last service I want to create is the account service. So let me go ahead and right click here, new, Kotlin class, call this account service, press enter, and then go ahead and use the service annotation. Import that. And now we're going to need to inject the dependencies we'll need specifically for the account service. So the first one I want to inject is the account repository, right? Because if I want to interact with the account table, I'm going to need the account repository. So go ahead and inject that. And the second thing I'm going to need is I'm going to need the user service, because I need to check if an account is associated to a specific user, or if a user exists to even save money to account. Remember, there's that relationship between both of these, between account and user. So I'm going to need both of these, right? And with the user service, I can go ahead and get a user by email, or if I need to add any additional helper methods, I could do that. Or even if I want to grab it directly, I could utilize the user repository from here as well. But um, I usually like grabbing things from the user service, right? I usually like working with the layer before the actual database, just in case. Now, let's start off with the methods for the account service. We're going to need to be able to save an account, but it can also be used to update an account. So what I'm going to do is I'm going to do function save account, and it's going to need an account. It's going to be of type account. Import that from the entity, and it's going to return the instance of the account after it's finished saving or updating. And I'm going to return account repository dot save because that's just going to return an instance of the account that was saved or updated. So there's that. We're going to need to be able to delete an account, right? Because maybe the person doesn't need a savings anymore or checkings. We can delete it. So I'm going to do delete account. Account is going to be what we're going to need as the parameter. And in this case, it's just going to be a unit, right? A unit just meaning, if you have experience with Java, it's like void, right? We're not returning any value back, right? It's just going to be a blank slate, right? When it comes to delete, you're not returning anything back to the user. The only thing that changes is probably the status code, which is going to be 204. So that's the main difference, right? We're deleting, we're removing it. If there's an exception that occurs, or if we're unable to delete the account, we can return a message back to the user in that case. But if it's successful, then we don't return anything back to the user. So we can do account repository dot delete and provide the entity that we want to delete. Or in this case, it's going to be the row that we want to delete. It's going to go ahead and check the ID that's in the account and go ahead and delete that. And you can, if you realize so far, we're using methods that we didn't even create ourselves. We're using methods that was created by the JPA repository. So saves a lot of time. The next method I'm going to create is find an account by an ID, right? So if a user passes an account ID, then we can go ahead and grab information regarding that account. So what I'm going to do is I'm going to do function find account or find account by ID. Go ahead and pass the ID. And what I'm going to return here, I'm going to return an optional of account, right? Because we're going to be able to check, and I got to import that as well. We're going to be able to use some methods to check if that account actually exists. So I'm going to use optional in that case. And what I'm going to return is account repository, find by ID, and pass that ID. Then lastly, I'm going to create an account, right? So a user will have the ability to create additional accounts and associate it to themselves, right? So if they want to create an additional checking account or saving account, they can do that. So I'm going to create a function called create account. And all they're going to need to do is provide the user ID, which is going to be retrieved from the JWT token. So they don't even have to provide it themselves. I'm just going to extract that value, right? And then the account type, right? So whether it's a saving or whether it's a checking, that has to be provided to create an account. And after creating it, I'm just going to return that account, right? It's going to have a new ID and it's going to be confirmed that it was actually saved. So and I just realized this now, because I got the user ID, what I'm going to need to do is I'm going to need to create another function called get user by ID. And I'm going to need to pass in the ID for the user. And I'm going to need to do find by ID. And in this case, find by ID is going to utilize the primary key. So we set the user ID as the primary key, of course, and then I'm not going to use the or else here, right? I'm going to actually attempt to return an optional here. Let me import that. And then from wherever I'm calling it, I can go ahead and check if it exists or not. So I can go back to account service. Then what I'm going to do is I'm going to create a variable to hold the user, right? So I'm going to attempt to call user service and get user by ID, pass in the user ID, and then I can do get. I'm going to use another one, get or else, and then I can go ahead and throw an exception, right? So there's multiple ways you can go and throw exceptions using optionals, but this is just another way I want to show. And I can put user not found. Then in the future, we're going to have a custom exception. This may be a 404 to let the user know that, or the client know that this user doesn't exist, so I can't go ahead and create that account for it. Most likely it will exist though, because like I said, I'm extracting that value from the JWT token, but just for security purposes. And then below here, what I can do is I can create an instance of an account and go ahead and start creating that account. So I'm going to do accounts, open up an instance of an account. And for account, I'm going to go ahead and define some of the values here. So account.name is going to be equal to, and by default, I'm just going to give it a default name. In the future, if you want to go ahead and create a separate method to change the name of an account, you can do that. But just to save time, I'm not. I'm just going to provide it a default name. And the default name is going to be first, the first name. Then I'm going to specify the account type name. So account type dot name. So the account type that was specified here. So whether it's a savings or a checking, is going to put the first name of the user, the type of account. And then at the end, to make it unique, I'm going to go ahead and use a UUID. So I'm going to do UUID dot random UUID, and this should make it unique, right? First name, the specific account type name, whether it's savings or checking, and then pretty much a random UUID at the end. And it's already associated to a specific user. So even if somebody else gets that UUID, it's going to be associated to another account anyway. So it's still going to, or another user. So it's still going to be considered unique in that way, regardless. And then what I'm going to do is provide a default balance of 0.0. Now, if you want to allow the user to provide a balance, or deposit it from the route of creating an account, you can. You just got to provide another parameter with that amount, or even use a DTO for that. But in my case, I'm just going to provide it a balance of 0 to start off. Then what I'm going to need the user for is I got to associate the user to this account. And to do that is going to be account.user and provide it the user. So now it's going to establish that relationship between account and the user, right? And then I'm going to do account.account type is going to be equal to account type. And then what I can do is I can return save account, which is up top, right? So this is useful, save account, and just go ahead and save that account. So that's pretty much it. So provide the name, provide the balance, provide the user that this account is associated to, the account type, and it's going to go ahead and use this save account method that I already created beforehand. And this is going to return an instance of an account. And when this is called from the controller will return that instance of an account back to the user, and it's going to have an ID associated to it. So if they want to add money to that account, transfer, send, whatever, now they have the ID associated to that specific account. And if there's any issues, like if that user is not found, or maybe something occurred while trying to save, then an exception will be thrown, and the user will be informed. So now that we have placeholder methods for some of the services, let's go ahead and get started on the authentication. We want to make sure that only the proper users are using our application and have access to what we want them to have access to. So we don't want anybody to just be able to withdraw money or transfer money or send money. We want to make sure that the user that is attempting to use our application is the actual user, right? So that's why this JWT token authentication that we're going to utilize is going to be very important. And once we have that set up, we can go ahead and dive a little bit deeper into our service layer to handle the logic and return information back to the user attempting to use our application. So let's dive into Spring Security.